we're going to have a chat about momentum. So the question is, would you rather get hit by a slow-moving brick or a fast-moving ping pong ball? Okay, so that's the question. So what are the things? So we've got Liam saying he'd rather get hit by a fast-moving ping pong ball. Ricky's going for the brick. Oh, okay, right, okay. So maybe I should bring some bricks and ping pong balls and start throwing them at you. It depends on the mass of the ping pong ball. So we've got questions like, yeah, ping pong balls are pretty standard. How heavy? Okay, so let's say the brick's 2 kilograms. Okay, so we're estimating. So someone's estimated the brick at 2 kgs. Okay, so a 2 kilogram brick. How heavy is the ping pong ball? 30 grams. Okay, so we're going to go for 30 grams for that. Okay, so we've got a 2 kilogram brick and a 30 gram ping pong ball. So we are interested in how heavy the things are. There's definitely one thing you want to know about before you make your choice. The angle it hits you. Let's say that they both hit you flush on the nose. They both hit you flush on the nose. Okay, none of this mucking about. You can get choosing to hit somewhere else with your brick if you want, Ricky, but we're going with the nose. A brick smack on the nose or a ping pong ball smack on the nose. So we've still got dispute. Ping pong ball, brick. How fast is it going? Okay. So the second question, how fast? Okay, so when I say slow moving or fast moving, it's not a very good definition, is it? So when Fitz is saying how far has it moved, if you're talking about it, falling, that'll definitely make a difference. If you're talking about it going at a constant velocity, it doesn't matter how far it's come from. So if the acceleration is due to distance, absolutely. But otherwise, the question is, how fast is it going? So what would you consider to be a fast-moving ping pong ball? How far? 100 meters per second. That's moving. 10 meters per second. Hey, I mean, when you look at that's pretty slow. When you do like tennis, we'll probably Google it. How fast a ping pong ball, MRIs onto it. How fast does someone serve a ping pong ball? We'll find out the fastest moving ping pong balls. And what do we call slow moving for a brick? 2 meters per second. That's about 10k. That's probably pretty slow, isn't it? So let's say the brick. So the brick can be doing 2 meters per second. That's 70 miles per hour. We've Googled it. So 70 miles per hour of a ping pong ball. So 113 kilometers an hour. So that's around about 30 meters per second, ballpark. So let's call that 30 meters per second. Okay, so that's how fast it goes in the Olympics. Oh, 50. Okay, we're going for 50. Zane reckons he could get 50 if he had the motivation of Ricky's nose to hit it at. Okay, so we're going for 50. Okay, so 50 meters per second for the ping pong ball. That's a fast-moving ping pong ball, faster than an Olympic ping pong server. You're aiming for your nose, which is a sizable target, but yeah. Okay, so we're going for. That's just to give us some ideas. Okay, so now how are we going to sort of compare those things? How do you merge so you're interested in the heaviness and the speed. So how are we going to merge those two things together? So this is the speed it hits you with. That's the speed when it contacts your nose. Yep. So where it's come from is irrelevant, just the speed that it hits your nose with. Yep. So we're going to times the two together. So sort of to get an idea of both of them together, we could times them. Okay, so let's have a look. So for the ping pong ball, we go 30 grams, which is 0.03 kilograms, times the 50 meters per second.
Who came up with 2 meters per second for brick? That's fast.
That's a fast brick, is it? That's too fast? So now you're backing out now. Now you're piking out. Doesn't want to get hit with that brick anymore. So So what's this? This is 0.15? 1.5. Now this is 1.5, and if we do the brick at 2 kilograms and 2 meters per second, that's 4, whatever we're talking about. So the brick has got more something than the ping pong ball. But like Ricky says, maybe it's a rather fast moving brick. So what would you consider to be a slow moving brick? 0.3. So Ricky wants the brick to be going 0.3 for a slower brick. But for a brick for chickens, 0.3 meters per second. Okay, so in that case, if we have the slow brick, the chicken brick, would be still 2 kilograms times 0.3 is 0.6. So we've got our fast ping pong ball at 1.5. We've got our slow but still scary brick at 4, and we've got our chicken brick at 0.6. Okay? So we've got 3 different numbers, and now you sort of start to say, what is this representing? This gives you a feel for. Yeah, it's something slightly different because it takes the time for it to stop. So it's how far it squashes your nose might make a difference. Okay, so Liam's used the word momentum, which is what we're calculating here. Okay, so this is what we call momentum. Okay, so momentum is just a combination of mass and velocity. If you multiply those two things together, you get momentum. Okay, so this is the momentum of the ping pong ball, and the units is just kilograms meters per second. So it's kilograms times meters per second. So all of these are kilograms meters per second. Yep, no, oops, slashed in the wrong place. Kilogram meter per second. And that's what we call momentum. And this does really tell us something. So the slow but scary brick has more momentum than the fast ping pong ball, which has more momentum than the very slow. I'm not afraid of that brick thing. Okay. That's me. See whether I'm a chicken or not. Yeah. Okay. So for all of these things, the formula we're using is momentum is mass times velocity. Okay. So the symbol for momentum is small p. M obviously already used for mass. So we go with P for momentum. So momentum is mass times velocity measured in kilogram meters per second.